Okay, this particular class right here is for programming the FujiNet. For those that don't know, the FujiNet is an 8-bit network adapter for Atari 8-bit machines. It will be coming to other machines shortly. You can start to get information by going to FujiNet.online, which will give you a good overview of what the network adapter can do in terms of its capabilities. But just as a quick overview, it provides a virtual disk interface, allowing you to load disk images over the network or through local storage. It provides a Wi-Fi modem. It provides a virtual printer, emulating a wide variety of printers. And perhaps most interestingly, it provides a full-blown network adapter that does protocol offloading of a wide variety of protocols. And that's what essentially I'm going to be talking about today, is showing you how you can take and create network applications using the programming language of your choice. And in this case, I'm going to be using Atari Basic for that. There's lots of wonderful bits of information that you can get to from the FujiNet.online website. One of the most important resources, especially when you're doing programming for the FujiNet, is to go to the support section and go to the GitHub Wiki. And the GitHub Wiki contains a wealth of information, not just in terms of contributed user documentation on how to use your FujiNet, but also all the programming information that you need, such as the commands that are supported for doing various network functions on FujiNet, both from CIO and SIO. For the purposes of demonstration, we're actually going to be using a wonderful page here called the Basic Networking Cheat Sheet, which shows you, among other things, how to take an open client connections, opening listening sockets, listening for connections, as well as sending, receiving data, and closing the connection. And for the game that we're doing here, we can actually show, I'm actually going to be doing the reversey example here, showing you how we take an existing game adapted in Atari Basic and give it networking capabilities so that two people can play a game of reversey over the network. To start, we need an Atari. Well, good thing here, I have a copy of Altera here, and I also have a copy of FujiNet PC, which also means that not only can you use a real FujiNet device, but you can run the FujiNet software on your PC and connect it to your emulator to take and do software development here using the debugging facilities that are available in the emulator, making development very nice. To start off with, it's actually very simple. We can go ahead, I will completely cold start everything here so that we go back to the FujiNet configuration menu here. And it's going to try to boot DOS. Pardon me while I take and reset the FujiNet just for a moment. And for those who haven't seen it, this is the configuration program that loads when you first turn on your FujiNet. It allows you to connect to both local and remote resources and to mount disk images to set everything up for your environment here. For what we're going to do, I'm actually going to take and use a disk image in the cloud on a host called atariapps.errata.online, which contains a wealth of pre-existing disk images for all sorts of uses. One of the best folders in here is the DOS folder, which contains a wide variety of DOSes, but most importantly, it contains all of the FujiNet utilities and the device driver that you need to use the network functions from other languages or other programs. For the sake of expediency, I'm going to choose OSS DOS XL, but you can do this from any DOS that you wish. I'm going to mount it here, and I'm going to go ahead and I'm going to create a new disk image on my local storage, or actually, sorry, on my local TNFS file server here, and call it Reversi. This will be a fairly standard 90 kilobyte diskette, single density. Say, yes, are you sure? Absolutely, and we're going to mount the result in drive 2. This is a blank disk, so we will have to format it. We'll do that next when we take and boot the system. Go ahead and press F4 to mount everything, if it will let me. Come on. There we go. And within a few moments, it will take and load DOSXL. And since the end device driver is loaded as auto-run sys, it will automatically load the end device handler for us and get it ready for use. And since this is a FujiNet startup disk, it also has the various FujiNet config utilities here that you can use at your disposal. One of them is fconfig, which will show you the current network configuration. We'll go ahead and we'll run init here to format a disk. We'll format a disk and write DOS/sys. Since we have the blank in drive 2, we go ahead and write it there. And it's already written the DOS for us. We go ahead and exit, and we copy a few things over there to help us out. One of those things, of course, is auto-run sys, which contains our end device driver, because we're going to need it when we take and boot into this. And we're going to copy a program called do.com, which allows us to do complex batch operations. Particularly, we're going to use it here to load our finished game automatically from the disk when everything starts up. And for the sake of just convenience, I'm going to go ahead and copy the copy command over there as well. Since copy is an extrinsic command in DOSXL, I need a copy of it over here as well. We still have plenty of space on the disk. Now, if we look at what we have DOS/sys, we have the end device handler as auto-run sys, which will load automatically when the disk is started, and the two utilities which will help us take and build out the last bits and pieces of what we need for this when we finish. So with that, I can go ahead, I can put my DOSXL disk away, which we can do that when we take and cold start the system. I'll use the freset command to do this. And we'll go ahead and eject this and put Reversi into drive 1 here. This is my local TNFS file server. I'll take and put this in, read write into drive 1. And we're just about ready to go. Now, one thing I will do here, since I'm running an Altera, and since Altera can speed up cassette access, which we really want to do in a 30-minute presentation, I will go ahead and load the game that we're going to convert from cassette. This is Roman Checkers. It was sold by Sears as one of the very first games available for the Atari 400-800 machines back in 1979. Okay. And with that, we'll go ahead and before we start actually adapting the game, though, I want to show you guys how easy it is to do network communication. To start, we're going to have a window open here. This is a terminal window on my local PC, and I'm going to be running a copy of Netcat, whose whole purpose is to take and listen for connections, accept those connections, and to echo anything that I send to it to this window. It's here listening on port 6502 on all interfaces. And all I have to do to take and establish a network connection is to use the open command that most of us basic programmers know and love in the first place. We're going to use the in device, which has been loaded by autorun.sys. In has a special format that it uses for its device specification, which allows you to specify the protocol that you're wanting to use, in this case TCP, the host name that you're going to connect to, in this case TMA2, separated by a colon, followed by the port number that you wish to listen to, ending with a slash. You'll see immediately that it went ahead and opened up a connection. Now, the one part that you may not be too familiar with is this second value right here. On the wiki, it just explains what this second value is used for. And in this case, we're telling FujiNet to translate carriage returns and line feeds automatically for us so that we don't have to do this in our code. And it will make it easier to communicate with this window over here. Oop, come on, quit it. Okay. All we have to do to send something over the connection, print it. And all we have to do to send something back is to input it. That's it. That is as simple as it gets. If you want to get single bytes, yes?
Isn't this really done with mirrors?
I tried to put as many smoke and mirrors in this as I possibly could. Okay, so that's it. You can use get and put to do individual bytes as well. And the field processing that's available in the input statement, doing comma-separated information, is also possible. So you can input data into multiple variables at the same time. And we're actually going to be using that in Reversi here. So with that, let's go ahead and start adapting our game. We'll go ahead and close the connection here, which will also close the Netcat connection over here. We're done with this for now. Okay, great. Now at this point, since I have a cassette loaded, I'm going to go ahead and just do a C load here. I'm going to let it do its thing, and you can see we do the little thing here. Since we have cassette acceleration turned on, it's pretty much instant, thank God. Because otherwise this would be very painful to wait. And we have our game here. Our game isn't that big to begin with. And in fact, if you want to take and have a nice little listing of this that you can put, that you can reference, you can send this to the virtual printer, and in a few moments, we can go pick it up in the web interface. Since I'm running FujiNet PC, this is running on my local host on port 8000. Are we done? Yes, we are. Okay. And since I'm using the HTML ASCII printer, I can take and download the finished printout with the Atari font and any special characters that may have shown up here. Very useful for printing out programming listings and the like. Thank you, Jeff, for working on the virtual printer. It's amazing. So you can see this program isn't that big to begin with. That also means that what we have to do to adapt it for network use isn't that big either. But to start, we'll just go ahead and run it real quick. We have type name, press return, Tom and Bob. It draws the display. It puts up the play field. Now, the first thing that you should always put in mind when you're trying to adapt something for network display, for network use, you need to think about in terms of the types of information that you need to be able to send across. Well, we know that we need to send, first of all, our player names, one to the other. And we know that we need to send our position information, such as when we're selecting a square, when we've selected a square. At the end of the day, that's really all we need to send for this game. Plus, I want to take and make a couple of small changes to the color scheme, because this is terrible. So we'll go ahead and break out of that. If I can. Come on. And yes, the N handler is resilient to resets, so it will stay in memory if you hit the reset button. So to start, we'll make a few adjustments here to the color palette, which is on lines 710 to 720. And for the case of expediency, I'm going to use the magic of cut and paste to do this. So we're going to take those colors right there, and we're going to put something a bit more palatable. Pardon the pun. Okay. Now, if we look at line 500, we'll see that these are all of the variables used in the game. We have A and B for player names. We have the current state of player, and we have board positions, essentially. Not much else. So all we need to do to that, we need to add an additional variable, essentially, for holding the host name, but we also need to add one to hold the device spec that we're going to construct from the host name. And we're going to add one more variable called ls, which is a flag indicating whether we're listening for a connection or if we have connected to another host. At that point, that gives us everything we need to kind of start up. We go ahead, open up the keyboard here, start up, type name, press return. Now this is where we start adding in the meat of what we're going to add for our game here. We're going to take and add a little message to the screen saying be sure to forward ports and ask for a host name as well as return to listen. Now, I'm going to use a particular trick here called input number 16. And this particular trick basically suppresses the question mark in an input statement. So if you've ever wanted to do that in Atari Basic, this is literally how you do it. We're going to take and see if the host name is blank, that is, you pressed enter, and if it is, we assume that we want to listen for a connection. And finally, we go ahead and we construct a device specification. Oops, my apologies. Using the string functions in Atari Basic to basically take the host name that we've input and put a device spec around it with the appropriate port. We then immediately open that device specification. Now, for the purposes of testing, I'm going to change the 0 to a 2, Again, so I can use this with my netcat window. Since netcat is running in Unix, and Unix uses line feeds by themselves for carriage returns, the two means just only deal with the line feed and not try to add an additional carriage return. If we're not listening, then we take and jump over this next part where we try to listen for the connection. Otherwise, we continuously put ourselves in a loop where we get the status of the connection that we just opened and see, based on status, if you've ever worked with status before, canonically, status puts its information in location 746 to 749. 748 in this case is where the end device driver puts its connected or not connected flag. So you can tell whether or not you've connected or not by seeing if you jump out of this loop. If we jump out of this loop at any given time, then we have a connection waiting for us to accept. And you'll notice I'm using a particular convention here called ASCA, and that's because otherwise this would be the number 65, which is the ASCII value for capital A. At least doing it this way, it becomes clear that we're essentially using capital letter A here to indicate that we're accepting a connection. At this point, if there's a connection waiting, it will take and bind it to the I/O channel of our choice, which in this case is number 2, and then continue on. At that point, the Atari has accepted the connection, and you can read and write to it. We then wait for a moment for that to finish. And I think, give me just a moment to take and turn off input for joystick here for just a split second. Well, there we go. And now we get down into 600 and 700. This whole section right here, we're basically going to be jumping over, because we really don't need all of it anymore, because some of this is being taken care of by the network now. So we start by saying, if we're not listening, let's go to line 620, where we ask for player 2's name. Otherwise, we take and get the player name from the network port, send ours, we send our network name, we get the other player's name, and then we immediately jump to start the game, which is on line 700. Conversely, if we are listening, then we do the opposite. Finally, we get to the meat of the game itself. And this is pretty much it in a nutshell. And we can zoom in a bit further to here, and you can see this is where we spend the majority of the time dealing with joystick or keyboard input and deciding what to do with that based on what we get from either the joystick or the keyboard. We'll go ahead and modify line 1510 ever so slightly, mostly because we're only dealing with one potential joystick or keyboard input, so we can simplify this just a little bit. Oops. Apologies. Do that again. And finally, we figure out if we're listening or not, and then we figure out if we need to take and jump back to the beginning of the loop. finally, we modify 1530 ever so slightly. To deal with the fact that we're now getting information out of the network. Now, to take and send our player information, this is all we have to do. You can see right here that we are constructing a string that sends the X and Y information separated by commas. And that will make it very easy to take and read the resulting inputs when we're done. We need to, for various different reasons, we need to do it not only when we move the cursor, but we also need to do it when the trigger is also depressed. And finally, if we look at the top of the program, you have various subroutines for different things that we need. In our case, we actually need to add an additional bit of code to after line 60 here, which is every time that the move changes and there's a delay here, but we also need to check to see if there's any input waiting by using the status command, and if there is, peak 746 will tell you how many bytes are waiting, and if it is, we go ahead, and because we've comma formatted everything ahead of time, we can simply take and input all of our variables at the same time. And if trigger is set, that means the trigger is pressed and we want to do the move, we go ahead and jump to the part of the code which takes and inputs the move to the game engine itself. That's it. Using a handful of lines of code here, using input and print statements, we've basically added network functionality to an existing game. And that took, what, 10 minutes? If we go ahead and start it, and I'm going to go ahead and I'm going to do the same thing I did before with this window here, and we're going to use netcat as our test so you can see what's happening across the network when we play this. Using the same port as before, netcat, listening, and we'll connect. Connection received, and we immediately put our player name here. Apologies. And I'll go ahead and put Bob. And the moment we do that, it's going to send that across the line here for us. And I'm going to take and respond with my player name over here. Now we'll see, we also see the new color changes as well. Now, I'm going to go ahead and turn on my joystick to arrows. Are you going to let me do this? No? Oh, wait, probably because I need to take and do it over here. And you'll see, as I take and send network commands over, it's actually taking and updating the position over here. Go ahead and do this again. Let's see. There we go. I'll select that piece. Is it going to be legal? No, it's not. I'm just kind of improvising here. But you can see how we can take and bounce back and forth. So we'll go ahead and stop this here. And I'm going to take and load this on another virtual Atari here. And we'll see if we can do a game. I'm really testing fate here. So for that, I'm going to go ahead and open up a virtual machine, which I have suspended. Come on. Come on, what are you doing? Are you not going to let me do this? Okay, we might be stuck here. I guess I can take and end it here, and if anybody has any questions, go ahead and ask.
What set you down this road?
You got another 2 hours? Well, basically, I wanted to create, Moswald and I wanted to create an 8-bit network adapter that was easy enough to use. And one of the use cases that we had when we were thinking about how we were going to program this thing, we knew we didn't want it to be like existing 8-bit network adapters like the Dragon Cart, Ethernet, et cetera, because those devices are notoriously difficult to program. We wanted something that if you wanted to submit something for the 10-liner basic contest, you could. And we wanted to maximize the ability to integrate into the operating system as best as we possibly could.
Tom, didn't it start as like an adapter to play this term box? Isn't that how it started?
That was one of the things that we wanted to do. I wanted to make good on a connectivity solution so that people could connect to Errata Online and services like it. And it just so happened that while we were going down that line, Moswald had created this ESP8266-like device, and more importantly, he had hooked up all the lines. And it all started with the basic question, is the command line hooked up? Well, if the command line is hooked up, that means I can simulate any device that we want to. And, well, proceed and interrupt is hooked up as well. So we were able to make network communication efficient. And it sort of went from there. The thought process became, how could we make something that integrated well into the Atari operating system and be able to utilize all of its various functions?
And then with all those lines hooked up, Moswell turned it into a MIDI device to do MIDI maze.
MIDI maze. And that's another part of it too. We're hoping to take and be able to take and generalize that so that other games that need constant stream-based input and output without disrupting the system, waiting for packets to come in, will be able to utilize that as well. Anything else?
What other systems do you have in the shoot next?
Well, we have Commodore 64 has been breathing now for a couple of months. Well, we have a couple of atoms here, Coleco atoms here, that I'm going to be doing the first bits of system bring up here once I finish here. I'm spending the rest of the day basically seeing if we can take the prototype boards that Moswald has express shipped over here to see if we can do the first network boot up with it. Apple II via the smart port, and if we can work out a bus interface, potentially other systems as well, not just computers, but game consoles. The beautiful thing about the ESP32, I only went over TCP communication in this particular round, but there are many protocols that the end device can actually deal with. HTTP, HTTPS, encrypted protocols such as SSH, SSL, etc. And the ESP32, since it's a much larger, much beefier machine, can handle all of the intricacies of talking that protocol, handling the encryption, and doing everything that it needs to do so that the Atari gets a nice, clean I/O interface.
Tom, what other languages, 8-bit languages, do you have examples of?
We have, if you actually, one of the nice examples that you have, if we actually go to the wiki page, you can see, for example, programming information, and we have a simple netcat program, which does exactly what you saw in my terminal window here, providing a basic terminal-like program. And we have examples of that in BASIC. As you can see right here, it's like 6 lines of code in BASIC. There's a version in C, using C65. There's a version entirely in assembler for those who want to do this in assembler. And there's also, I did another example and another series of videos showing how to do that same program in action. But basically, any language that you want to use on the Atari, you can. I've even done this from Logo. Pilot should work, but it does something very, very nasty to the device handler table that I haven't been able to figure out what's happening yet. But it would have worked from Pilot as well. Basically, anything that supports central input and output will work. And if you don't want to use central input and output, you can talk directly over SIO.
Less technical, but what's the inspiration for the name?
You can thank Kay Savitz for that name. Originally, this project was called Atari Wi-Fi, but we changed that because said company tends to be rather lawsuit happy. So we decided we needed a quick name, and Kay kind of threw it out there and went, oh, that works. And, you know, Atari, Fuji, you know, logo worked out perfect. So. Plus, it's just generic enough that people who aren't as familiar with Atari can basically aren't going to immediately go, ooh, the Atari thing, I'm not going to touch it. So. Any other questions? Okay, thank you very much.
How do people get one, Tom?
That's the beautiful thing. FujiNet is an open source project. Open source in terms of software and in terms of hardware. This means that we have multiple vendors that are building these. You can get a FujiNet either from FujiNet.online when Moswald builds limited runs. You can get them from the Vintage Computer Center, VCC, and you can get them from the Brewing Academy as well. In Europe, you can get them from Zaxxon and retrolemon.uk. Anybody who wants to take and be a vendor, we can work with them to bootstrap them to show them how to make it. Because we want this thing to be used everywhere.
Do you have any idea how many of them sold?
Yeah, actually, close to 2,000 since the version 1.0 late last year. I know, I'm surprised too.